Hello everyone, today we're going to go over some Blind 75 C++, and today we're going to be focusing on how to find the maximum depth of a binary tree. So, before we get started, always breaking down the question, we need to ask ourselves what the input's going to be, what data structure / algorithm / technique we need to use, what to do with the data, and what our output is going to be. So, going over the question, given the root of a binary tree, return its maximum depth. Okay, so we are given a tree, and we need to return maximum depth. And so the technique we're going to be doing is depth first search. Hence in the name, it's useful to find the depth. And then there are typically two techniques in trees, breadth first search and depth first search. Depth first search utilizes more of a stack. Breadth first search uses a queue in this case, but C++ and their STL library is very intuitive when it comes to their own library, and so we'll just be focusing on leveraging on that. And it's really 4 easy steps to go over, so it's going to be really fast. So the first step we're going to do, we're going to have our edge case when we don't have any value in the root. Root is equal to null. Second step we will have is calculate the maximum depth of the left subtree. Then we'll do the same for the right. Finally, return the max depth of both the left and right subtrees plus 1 to include the root. Alright, so this will be straightforward. So if root equals null PTR, we return 0. Since we don't have anything in here, and we are returning a number, and then with step 2, the maximum left, so int left is going to be equal to the max depth of root of left. And we'll do the same thing for the right. And then finally step 4. Just gonna make sure we have everything already set and it is right. Alright, passes all the test cases. And here we go. Woohoo, that was quick and efficient. Okay, just be able to give a rundown and breakdown of everything we already did. So, the time complexity for our following solution is going to be O of n, where n is representing the number of nodes in the tree to start, and that we are finding both the right and left depths of our following tree. We have to keep track of all of the nodes that have been visited to be able to get our max depth. And then the space complexity is going to be O of h, where h is referring to the max height or max depth of the tree overall, and so we need to store those values accordingly, so that way we can be able to have our following solution of getting the max depth of our tree. And I realized I made a spell check error in my front. I will fix that. A couple of them. I apologize on that. I know it's kind of dumb. And here I am running the test cases when I'm just doing the comments. I'm just trying to make sure this is all clean. So, yeah, this is pretty much it. This is finding the maximum depth of a binary tree. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And then if you have any questions, please put them in the comment section. And as always, take care. Cheers.